Okay, guys, okay. So let's go ahead and grade our homework. Let's go ahead and check your answers for me, please. All right, and pay attention to the details. The first thing you had to do, and that's why I was kind of wondering where you guys did all your work. I wanted to know if you were able to get the hypotenuse of your triangle using Pythagorean's theorem. Hopefully you said the square root of 53. We cannot simplify this radical because 53 is prime. Okay, now, I do want to show you something that might help you. 53 probably to most of you was obvious that it was prime. But sometimes if it's not so obvious, let's use our calculator and let's see. And I want you doing this with me, okay? Because this is actually kind of helpful. So grab those calculators for me and let's do something real fast. All right? So I need you to go to y equals. And I need you to put in the equation 53 divided by your x variable. So in your y equals, put 53 divided by x. Then what we're going to do is we're going to look at the table. And when you go to the table, you are going to see where we're trying to figure out if 53 has any other factors. All right? And what the calculator would do for us is first thing it'll take 53 and divide by 1, 53 and divide by 2, and then it'll divide by 3, and it'll divide by 4, and divide by 5. And so when you can divide evenly into a number, that means you are a factor of it. If it doesn't divide evenly and you get a decimal, then that means it's not a factor. Okay? So primes only have two factors, the number itself and 1. So let's look at the table. Go to second graph for me. Go to second graph. Your table needs to start at 1. So I'm going to have to kind of, mine is down at like 34. Okay, give me a second. Let me get back to 1 so we can talk about everything you see there. Okay, are you guys with me? By the way, division by zeros undefined. That's why you see error. Division by zeros undefined. Okay, so that error is correct. Don't think you've made a mistake. That is actually correct. Now, let's go down through the list. So we know 53 is evenly divisible by 1. We know that. Okay, so that one you really don't even look at either. Look at all of the other y values and go down your list and you see decimal after decimal after decimal, which tells you what? These numbers are not evenly divisible by 53. They can't divide evenly into 53. Now, my suggestion is maybe just go all the way down through. See, you've got some primes coming up, like the number 29. See, I've already gone 1 through 29, and everything I've seen has been a decimal. And pretty much if you go all the way 29 with it, then pretty much you can guarantee that it is a prime. So let me go back up. Do you guys see all those decimals under my y value? I don't see one single whole number. I see nothing but decimals. So that tells you that that number is prime. Okay? All right, so we cannot simplify that radical. Square root of 53 is the length of our hypotenuse. All right? Now, the next thing I like to do is I like to just simply write the values from least to greatest. We have a length of 2, 7, and our square root of 53. And then I label them according to where my reference angle is. So 2 is the opposite side, 7 is the adjacent side, our hypotenuse is square root of 53. Okay, here we go. Ready? Uh-huh. You want to copy all that? Mm-hmm. Okay, yeah. Oh, and let me say this while you're doing that. I saw a lot of you simply using 53 as the length of the hypotenuse. You know, sometimes if you just sit back and look at a problem, you can catch your own mistake.
Well, the hypotenuse is always going to be square root.
It'll be a whole number, but my point, I was going to make this point. If you've got a leg that's 2 and another leg that's 7, and if you place those sticks so that they form a right angle, and again, we talked about this yesterday, this worksheet is not at all to proportion. Because if it's 2, it's actually only going to be about this high. But guys, if you have a leg that's 2 and another leg that's 7, Is your third leg going to be 53? Are you listening? Are you with me? If you have a leg that's 2 and another leg that's 7, and you put another stick down, and that stick is supposed to connect these 2 points, is that stick going to be 53 in length? No. No, no, no. All right, so try to catch your own mistakes. The square root of 53 is a tad larger than 7. How do I know that? How do I know that the square root of 53 is larger than 7? The square root of 53 is larger than the square root of what? 49?
See, that's what I was talking about, because 7's
Okay, yeah. So 53 is, square root of 53 is the largest of all the values. It's actually a tad larger than 7. All right, here we go, guys. Let's check those answers. All right, so the cosine of beta, our final answer should have been 7 square roots of 53 over 53. Your sine of beta answer should have been 2 square roots of 53 divided by 53. The tangent, the opposite over the adjacent, is simply 2/7. If you give the reciprocal of those values, now we talked about this yesterday, but let me go back again. So when you know you have to invert the fraction, and I look back, and I have actually 2 fractions for cosine. I have the one that I wrote when I put the adjacent and divided it by my hypotenuse. And then I have the answer where I had to rationalize my denominator, which you have to do, by the way. But look at these 2. Which one of these do you want to invert to give that secant value? The one with the radical in the denominator. You don't have to do any work after inverting it. Your square root of 53 goes up, your 7 goes down, and you're done. You don't have to do any more work. Okay, so let's find the reciprocal of our sine of beta. And these are my 2 fractions. Which one of these do I want to invert to find my cosecant? The first one, absolutely, guys. So your square root of 53 goes up to your numerator, 2 goes to your denominator. All right, good job. And then finally, the cotangent of our beta is 7/2. Just invert your fraction. They're the reciprocals. Okay?
Can I say
Sure.
the thing that I'm not getting is the cosine and sine,
Mm-hmm.
like putting the thing on top.
Okay. Rationalizing our denominator.
Yeah,
We
I
will
got-
definitely work on
I
that.
got all of them right except cosine and sine.
Okay, thank you for telling me that. We will definitely work on that. Okay, let's check your number 4. Let's check your number 4. And let's see here, guys. We had to find the hypotenuse, right? And I got down to the point where my c squared was set equal to 109. C squared was set equal to 109. So I wanted to check real fast in my calculator. I'm going to do exactly the same process I did just a second ago. I'm going to go to y equals, and I'm going to put 109 divided by my x variable. And what the calculator is going to do for me is it's going to plug a 1 in, then a 2, then a 3, and it's going to divide my 109 by all of the whole numbers, and it's going to tell me whether or not it's prime or not, because if I get all decimals, we're going to go all the way to 29 with this. All right, so let me look at my table. Second graph. All right, here I go. And you're looking at those y values, and if you see decimal after decimal after decimal, and usually if you go to 29 and everything's a decimal, you can pretty much guarantee that it's a prime number. All right, guys, I see nothing but decimals. If you want to, go to 31. And if you want to, now 33 is not prime, right? Who could tell me the next prime after 31? Is it 37? Okay. So I've already gone to 37, and I'm pretty convinced that this is prime. There's 41, and I still have a decimal, so 109 more than likely is prime, okay? All right, so Now, here's the deal though. Please, please, please don't use 109. It's not 109, it's the square root of 109. It's the square root of 109, okay? Alright, let's do what we did just a second ago. 109, the square root of 109, is a tad larger than what? 10. Thank you. Very good. How did you know that? Yes, because you know the square root of 109 is a tad larger than the square root of what? 100. Good job. Very good. So more than likely it's a 10 point something or another, right? Okay? It's not 11 because that would be 121. It falls between the square root of 10 and the square root of 100 and the square root of 121. All right, good job. Thank you. All right, so then I always write mine from least to greatest and then identify these legs based on your reference angle. So 3 is the adjacent side, 10 is the opposite side, and our hypotenuse, of course, is our square root of 109. Okay, so then I found my values, and we will work on rationalizing that denominator, okay? We'll work on that. We will. All right, check those answers for me, please. Hopefully you got that the cosine of our beta is equal to, our final answer is 3 on the square root of 109. That's divided by 109. The sine of beta, final answer, 10 square root of 109 divided by 109. The tangent answer, opposite over adjacent, is 10/3. Secant, again, let's talk about it. You have to invert the fraction on cosine. All right, guys, you've got this fraction, your original, and you've got your final answer. Which one of these are we going to invert to get our secant answer? The first one, the original, okay? So that makes our secant value a square root of 109 over 3. Cosecant, square root of 109 over 10. And then if you invert your tangent answer, you get 3/10. So the cotangent of beta is 3/10. All right, how do we do on that? Did anybody get all those correct? Anybody? Okay. All right, guys, let's do some more. Let's find where we're having trouble. All right, here we go. I want us to start number 7. And you're going to work independently on finding the missing side, and then we'll come back together, okay? Nicholas, are you okay this morning? You don't think you have the flu, do you? No. Okay. All right, guys, here we go. I'm going to let you dive in, find the missing side. Got to make sure we're doing this correctly. You know, Brady said something just a minute ago, and let me kind of talk about it. All right. If your values do not fit a Pythagorean triple, your 3, 4, 5, your 5, 12, 13, all of those Pythagorean triples, if the values you see do not fit a Pythagorean triple, then the side you're looking for will be a radical. And you said that just a minute ago, and you were kind of on to something. So do you see values that fit a triple? 5, 9, followed by the hypotenuse. Is that one of our triples? No. So what will the hypotenuse be? It will be a radical. It will be a square root of something. Okay?
So what you do is
Pythagorean's theorem.
Square root of 1.
We
Do 9
follow.
squared times 5 squared.
Yeah,
And then what?
Yes, please take the square root.
And then that'll be my.
And it doesn't matter what A or what B is. Some teachers tell you to put the smaller number in A. Please follow order of operation. Aunt Sally is always last, right? So please don't add the 5 and the 9.
I don't even remember what.
You want to do your exponents?
Oh, yeah.
Okay. So far, so good, guys. Anybody want to give me our number? 106. C squared is 106. All right. You know, when I find an even number, I am inclined to think possibly it's not prime. So what I want to do is I want to kind of carry you back to your good old Algebra 1 days. Do y'all remember breaking it down using primes? All right, let's see. Let's go with it. Here we go. So the first prime I'm going to use is 2. I'm dividing. 2 into 106. Somebody? 53. Okay. Now, I'm kind of thinking maybe 53 is prime.
I know that.
Now, 106 is not prime, but 53 is prime. And because 53 is prime and 2 is prime, we're not able to find a pair of factors. A pair of factors, we would be able to simplify this radical if we found a pair. Like if you were able to get 2 2s or 2 3s or 2 5s, you would have a perfect square, but you don't. Now 106 is not prime, but we weren't able to break it down using our perfect squares. So that is it. You are done. Your C, your hypotenuse, is a square root of 106. Alright, so I'm going to take that number and I'm going to put it back up here. My hypotenuse is the square root of 106. And that number is a tad larger than what? It is larger than 9. But it's also a tad larger than what? 10. Yes. That square root of 106, he is definitely a tad larger than a square root of 100. So he's a tad larger than 10, right? Okay. So does that answer make sense? Yes, that answer makes sense. All right. You want to kind of use your, common sense a little bit and make sure, does that look like a line segment that might be 10 or a little longer? Yes, that would be a good estimate. All right, here we go. Ready? Do you know what your ratio is for, hang on just a minute, guys. I didn't put my reference angle in there. Number 7, we have a gamma. Okay, here we go. Let me identify my parts. I haven't even done that yet. Sorry, kind of got ahead of myself. Here we go. Ready? From least to greatest, what are the side lengths? 5 9, square root of 106. All right, can you identify the parts for me? Well, I know 106 is definitely the hypotenuse. What is the 5? Opposite. There you go. And so 9 has to be the what? Adjacent side. All right, good deal. Very good. All right, here we go. Now, all I need is this information. This will give me everything I need. All right, what is the ratio for cosine? Anybody? Is that adjacent divided by hypotenuse? Okay, give me those values. 9 divided by the square root of 106. Okay, here we go. Are you ready? All right, let's rationalize the denominator. So the whole point is that you don't want that square root of 106 in your denominator. And so to create a rational, you simply multiply a square root of 106 by itself. The square root of 106 times the square root of 106 gives it is 106, okay? Because what's happening here, guys, is that you've got a square root of a 106 quantity squared, Well, you know how a square root and a square are inverse operations and they undo each other? What if this square that I have on my 106 undid? I know that's probably not even a word, undid. So what if one undoes the other? Then you simply have what? 106. So, and that's the whole point. I mean, that you made that happen deliberately. Now, what you do to the denominator, you have to do to the numerator also. Okay? You're not changing the value of it, you're changing the way it looks. Pretty much. Okay? So what is your numerator now? 9 on a square root of 106. Now, you always want to check, though, and make sure that your fraction, you have a 9 dividing a 106 now. And do you know the divisibility rule for 9? It's the same as your divisibility rule for 3. What's your divisibility rule for 9? You know your rule for 3. Is that the one where we add the digits? And if it's divisible by 3, you can divide that number by 3. Well, it's the same thing for 9, except you add the digits. And if that number's divisible by 9, you can divide by 9. So add these digits for me. We get 7. You can't divide 7 by 9. So we're done. Okay? You can't divide 7 by 3 either. Alright? So that's done. That's a keeper. Alright, what about the sign? Give me my ratio. What is it? Opposite divided by the hypotenuse. What is the opposite side? 5. Divided by the square root of 106, your hypotenuse. Now, can you guys go straight to it? Can you multiply top and bottom by a square root of 106? Can you do that mentally? And tell me what you get? 5 will be on the square root of 106. And your new denominator is 106. Double check that fraction, your 5 and your 106. That's a fraction, guys. Can you reduce that in any way? No. Okay, what about the tangent? Opposite over adjacent, or the numerator of your sine function divided by the numerator of your cosine. In this one, it's probably just as easy to do opposite over adjacent. What would that be? 5/9? Okay. Now, let's go back and let's give the reciprocals. I kind of didn't leave myself a lot of room here, did I? Alright, here we go. Yeah, these actually kind of, after you've done those 3, these kind of fall into place quite easily. Alright, guys, so what about secant? Okay, good. Your square root of 106 goes up. Your 9 goes down. The reciprocal, just invert your fraction. What about the cosecant value? Square root of 106 goes up to my numerator. 5 goes down to my denominator. And finally, cotangent. 9/5. Alright, good job. Very good. Okay. Do we need to do one more? Do I need to leave you alone completely? Which is something I don't do a lot of. I think we might be ready.
Did you record your stuff?
I am. I hope I am. I pressed the button.
Why is she recording stuff?
Okay. I'm on a private YouTube channel. I'm not sure they want me on it, for sure. I just hope other people don't get on here because they will laugh. Oh, they will laugh.
I may get on it.
Well, it was private then.
Supposedly it's private. It's only open up to kids at our school. Alright guys, here we go. I am going to leave you alone for just a little bit. We've got to be able to do one of these from start to finish by ourselves. Brady, can you work one for me? Okay, just step outside then. Let's try to get this one done in 3 minutes. Yeah, we can do that.
It's not 8 grade.
Well, the first thing you have to do is what?
A squared plus B squared equals C squared.
Mm-hmm. And on this problem, you're looking for what? One of your sides, one of your legs. All right, does everybody know we're doing number 8? We're doing number 8 on worksheet 1B. And I'm going to pull my paper away so I can work it. Okay, this one just got nice all of a sudden.
Limousine, when you just said.
Okay, I'll be quiet. I'll be quiet. I'm sorry.
There, I'm not scared, it's good.
I get a little excited, Brady. I'm sorry.
You German, sounds weird.
It's the LA version.
That's the first one five.
Maybe.
Ain't no maybe about it. Yeah, I know it is. Divide that. Remember, I know it ain't. Oh, it is. See? See? I was wrong. Wow.
Oh, listen.
Uh-huh.
Me and a few others, FBLA is good.
Is that tomorrow?
Yes, ma'am.
FBLA?
This ain't, you know, they just hurt my feelings.
What did they say?
They were so surprised because I admitted something wrong.
Okay, are you guys done? This is the time of year where we need to just pump y'all full of Mountain Dew.
I'm just so tired.
I'm okay with that.
I'm stepping ahead of you.
All right, here we go. So, did you guys find that the missing leg was the square root of 81? And then the square root of 81 is what? 9. And so when you put it into the triple, least to greatest, what else did you discover? Thank you. 3, 4, 5. Good job. Who discovered the 3, 4, 5? Awesome. And you know what? I'm going to tell you guys, this looks like the problems they put on the ACT. Yeah, I haven't seen many radical answers on the ACT, but they love to slip in. I think I told you guys this last week. On the ACT, they love the 5, 12, 13. And then they love the multiples. Do you guys remember me telling you this? The multiples of your 3, 4, 5. And that's what this one is. And that's what they love on ACT. So if you can memorize your 5, 12, 13, and then be able to recognize the multiples of a 3, 4, 5, you'll pretty much have the ACT down pat as far as right triangles, okay? All right, here we go. Let's check those answers. Did you get your cosine value as 4/5? Adjacent of hypotenuse? Did you get your sine value as 3/5? Because 3 was the opposite side. Is your tangent value 3/4? And your secant is simply the reciprocal, 5/4. Cosecant, 5/3. Cotan is 4/3. Okay, we need some more work, don't we?
You got like 30 seconds.
I know. Alright, here we go. We're gonna do a couple more tonight. We gotta get this down pat. Did we work 7 together? Yes, we did. We just need to work number 9. Okay, guys, worksheet 1B, show all work on notebook paper, number 9. Okay? Alright, today is Tuesday. Alright, you guys have a great day.
I'll try this one. It's hard to line it.
You don't tell me what.
Now.
I don't want to have a good day. If I want to cry myself to sleep, I'm going to cry myself to sleep. Yeah, that's a.
I felt that.
I felt that too. I didn't cry myself to sleep.
I